In this section, we will explore the foundation of TCP/IP. That will include a review of the headers and the concept of encapsulation and how it looks on the network. We will learn about the network protocols. Following this, we will examine the encapsulation process and what it means on the network. Then we will close out this section with a brief exploration of the headers of the different protocols. The Internet was built with an openness and trust. Part of this was the creation of protocols for communication. These protocols were when the Internet was very small and there was no need for protection. So this led to the protocols being developed with this sense of trust. Then today, more than 40 years later, we are still running these same trusted protocols. Therein lies the problem and why there are so many attacks today. These protocols were not made for a network of the size that we have today. There is a requirement to provide information to the network at each layer of the communication. This is in the form of a header. This identifies the data to the receiver, and it's essential that we understand these headers. They are the key to what's taking place within the packet. Within the network, we have this process of wrapping the information within things, encapsulation. Everything within our network is encapsulated. Each layer has its own specific function for each header for this. This is an example of the OSI model in encapsulation. So as you can see here, each layer has an associated header that identifies what's taking place. This continues until we get to the physical layer, which is our binary ones and zeros. Encapsulation. We now want to look at this in our total Wireshark. As this image shows, we have the data all encapsulated within the frame. This is followed by the Ethernet, and then the IP, followed by the encapsulated protocol, which in this example is UDP. This shows us how the network protocols are contained within one another. In this image, we're looking how the data flows between machines, and more importantly, between the layers of the network model, both logically and physically. Physically down the stack and then up the stack from the sender to the receiver. At each layer logically, the same function is taking place within the sender and the receiver. This is the IP header. This image shows the IPv4 header. And what we want to look at here is this, the protocol field. This is where that encapsulated protocol is identified. This image shows the UDP header, and as you can see, the header is very simple. Again, this is because it's connectionless and does not require any method to provide reliability. So it can be simple, as you see here. We have the source port and the destination port. This identifies the data to the service that receives it. This image, we have the TCP header, and this has quite a bit of data within. That's because we have to maintain that guarantee and that reliable service. We will not review all the information here. For now, we will look at the fact that it has the same important information as that of the source port and the destination port, so it identifies the service to and from. It also has these two fields for sequence and acknowledgement number. This allows for the connection-oriented requirement. Finally, within this header, you see these here. These are the flags or control bits of TCP. And each one of these identify additional details about the packet. In this section, we have explored network protocols. We explained and showed examples in the encapsulation process. We closed out the section with a brief look at the headers of the different protocols. Next, we will explore the information with a static packet capture file within the Wireshark tool.